just draw something that kind of looks like that. First of all, let's talk about maximums and minimums. This point of the graph and this point of the graph, what do you think those are? Is that a maximum or a minimum? Maximum. So this is a maximum, and this is a maximum. We have two types of maximums. The book calls them local. Local means just around that point. And then we have something called absolute. Absolute would mean it's the absolute maximum of the entire graph. Okay. So what kind is this? Yeah, that is an absolute maximum. Now, is it also a local maximum? Yeah, but that kind of trumps that. Okay, this is absolute. It's the highest point of the whole graph. Is this still a high point of the graph? Yeah, but it's not the highest of the entire function, so we would call this local. Okay, now, that, what's that called, what I just circled? A minimum. Okay, and I'm going to just point out for you that I drew these on my graph. So, think hard on this one. Is this absolute or local? Good. This one just doesn't have an absolute maximum, or minimum, excuse me, because it goes forever. You guys are so smart. You are. Okay. Good. Now, let me talk about, while I'm here, bounded. Do you see that this graph goes down forever? It is not bounded below. Bounded means that it doesn't go below a certain point. The only way it goes, or it's bounded below, is if it would have an absolute minimum. Okay? But if something has an absolute maximum, I'm going to just draw a little boundary line here. We would say that this function is bounded above. And if we would, let's say we would graph this on our graphing calculator and find out what that y value was, we could even say what it was. It's bounded above by the number, I don't know, 10. Okay. Now, there's some functions, let me give you this one, which you're going to get used to it. What curve is this? Does it look like I'm drawing? Sine curve. There's some functions that, this is 1 and that's -1, and doesn't that behavior keep going with the sine function? So this one is bounded above and below, isn't it? And so instead of saying bounded above and below, we just say it's bounded. If I say it's bounded, that means there's boundaries above and below. Okay, because it stays kind of within there. Common sense so far? Okay. Then the last thing I'm going to do is on these, I'm going to put some points, some made up points. I'm going to say this is -5, -1. I'm going to say this point is -10, 6. And I'm going to say this point is 12, 22. Randomly just making those up. So would you put some ordered pairs on there? So the last thing I want to talk about is where the function is increasing and decreasing. And again, this is common sense. Where is it increasing? Where is f of x going up? Where is it going down? Sometimes if it's flat line, we say where is it constant if there's a flat line. But here's the tricky thing. Sometimes people want to tell me the y values. Write in your notes, I want to know what x values is the function, I should say for what x values, that would be more proper grammar. For what x values is the function increasing and decreasing? And this is where interval notation is kind of cool, so we don't have to write out a whole sentence. Okay, so you guys tell me, let's start with increasing. Where does the function, what x value does the function start increasing? Oh, I heard somebody say negative infinity. Isn't it first going up from left to right? So I'm going to, over here, we would call that negative infinity. Very good. And until which x value is it increasing then? Good. All right, so I'm going to write increasing. And again, I'm describing x values from x is negative infinity to negative 10. I want to know where. Okay. Then what happens? Then it switches to decreasing from x is negative 10 to x is negative 5. Agreed? So then I'm going to say, okay, it's decreasing from when x is negative 10 to negative 5. Then what happens? Now the function switches to increasing again. I'm going to just add that up here. Remember that union thing? Okay. Now it's increasing from where to where? From when x is negative 5 to x is 12. And then the function now is decreasing from 12 to the rest of the graph.